Welcome to Fuzzy Mathematics, the Basics. In the previous lecture, we have talked about three kinds of operations on fuzzy sets: the union, the intersection, and the complementation. In this lecture, we are going to do some examples. First, example 1. Suppose X is the set with the 5 elements A, B, C, D, and E. Suppose A and B are two fuzzy sets in the universal set, denoted with jaded notations. The fuzzy set A equals 0.1 over A plus 0.4 over B plus 1 over C plus 0.3 over D plus 0.7 over E. What does that mean? That means the degree of membership of element A in this fuzzy set is 0.1. The degree of membership of element B in this fuzzy set is 0.4. The degree of membership of element C in this fuzzy set is 1. The degree of membership of element D in this fuzzy set is 0.3. And the degree of membership of element E in this fuzzy set is 0.7. The fuzzy set B equals 0.5 over A plus 0.6 over B plus 0.8 over C plus 0.2 over D. We know the meaning of this formula. Here is the question. What is the degree of membership of element E in fuzzy set B? The degree of membership of element E in this fuzzy set is 0. If there is an element such that its degree of membership is 0, then the corresponding term could be omitted. First, let's find the union of the two fuzzy sets. The degree of membership of element X in the union of A and B is the maximum of mu sub A of X and mu sub B of X. So the degree of membership of element A in the union is the maximum of 0.1 and 0.5. That is 0.5. Similarly, you can get the degree of membership of element B in the union is 0.6. The degree of membership of element C in the union is 1. The degree of membership of element D in the union is 0.3. And the degree of membership of element E in the union is the maximum of 0.7 and 0. It is 0.7. Next, the intersection of the two fuzzy sets. The degree of membership of element X in the intersection of A and B is the minimum of mu sub A of X and mu sub B of X. So, the degree of membership of element A in the intersection is the minimum of 0.1 and 0.5. That is 0.1. Similarly, you can get the degree of membership of element B in the intersection is 0.4. The degree of membership of element C in the intersection is 0.8. The degree of membership of element D in the intersection is 0.2. The degree of membership of element E in the intersection is the minimum of 0.7 and 0. That is 0. The degree of membership of element E in the intersection is 0. So, the last term could be omitted. Next, the complement of A. The degree of membership of element X in the complement of A equals 1 minus mu sub A of X. So, the degree of membership of element A in the complement is 1 minus 0.1. That is 0.9. Similarly, you can get the degree of membership of element B in the complement is 0.6. The degree of membership of element C in the complement is 0. The degree of membership of element D in the complement is 0.7. The degree of membership of element E in the complement is 0.3. The degree of membership of element C in the complement is 0. So this term could be omitted. Another example, example 2. Let X be the set of all possible numbers of one's age, the closed interval from 0 to 150. Let Y be the fuzzy set young, and O be the fuzzy set old. And the membership functions are illustrated as follows. Mu sub Y of X equals 1 if X is less than or equal to 25, and mu sub Y of X equals the reciprocal of the quantity 1 plus X minus 25 over 5 squared if X is greater than 25. If one's age is less than or equal to 25, then his or her degree of membership in the fuzzy set young is 1. He or she is 100% young. If one's age is greater than 25, then the membership function decreases rapidly. Mu sub O of X equals 0 if X is less than or equal to 50, and mu sub O of X equals the reciprocal of the quantity 1 plus X minus 50 over 5 to the negative 2 if X is greater than 50. If one's age is less than or equal to 50, then his or her degree of membership in the fuzzy set old is 0. He or she is not old. Find the union, the intersection of the two fuzzy sets, the complement of Y and the complement of O. What are their membership functions? First, let's draw the graphs of the membership functions of the two fuzzy sets in one figure. The blue one represents the membership function of the fuzzy set Y, and the red one represents the membership function of fuzzy set O. By the definition of union of fuzzy sets, the degree of membership of element X in the union is the maximum of mu sub Y of X and mu sub O of X. Before we write down the formula of the membership function of the union, let's take a look at the graph of the membership function of the union. If X is less than or equal to 25, its degree of membership is 1, and if X is greater than 25, the membership function decreases rapidly along the blue curve till this point where the two curves meet. Then the membership function increases rapidly along the red curve. Now we know that the membership function of the union is a piecewise function. We need to figure out the horizontal ordinate of this point. Actually, it is 50.96. Let's write down the membership function of the union. If someone is very young, then he or she has a high degree of membership of the union. If someone is very old, then he or she has a high degree of membership of the union. Next, intersection. By the definition of intersection of fuzzy sets, the degree of membership of element X in the intersection is the minimum of mu sub Y of X and mu sub O of X. Again, before we write down the formula of the membership function of the intersection, let's take a look at the graph of the membership function of the intersection. If X is less than or equal to 50, its degree of membership is 0. And if X is bigger than 50, the membership function increases slightly along the red curve till this point where the two curves meet. Then the membership function decreases along the blue curve. Let's write down the membership function of the intersection. If one's age is less than or equal to 50, then his or her degree of membership in the intersection is 0. If one's age is greater than 50, then the membership function increases slightly, and then the membership function decreases and goes to 0. In fact, no one could be both young and old. Next, the complementation of Y. By the definition of complementation, the degree of membership of element X in the complement of Y equals 1 minus mu sub Y of X. The red curve represents the fuzzy set young, and the blue one represents not young. If X is less than or equal to 25, the degree of membership of X in the complement is 0. As one gets older, the membership function increases rapidly and goes approximately to 1. Next, the complement of O. By the definition of complementation, the degree of membership of element X in the complement of O equals 1 minus mu sub O of X. The red curve represents the fuzzy set old, and the blue one represents not old. If X is less than or equal to 50, the degree of membership of X in the complement is 1. If X is greater than 50, then the membership function decreases rapidly and goes to 0. I'd like to end this lecture by 2 more questions. You may solve them by yourself. First, determine whether each of the statements is true or false. Next, determine whether each of the statements is true or false. Next time, we are going to talk about the properties of operations on fuzzy sets. Thank you.